Hello mathematicians, we're now going to look at the fundamental theorem of calculus. And believe it or not, we've already done this. So the formal statement is, for a function that is continuous over a domain, then this. So the integral of the function, the definite integral of the function from a to b of fx dx equals the primitive with the value of b, that should be a lowercase b in there, with the value of b minus the primitive with the value of a. So this is exactly the process that we introduced in our last video. So what we're going to show, again, following on from our last video, is that this definite integral can be used to find the area under any curves where we can find the primitive function. And we can't always, which is something we're going to discover. So remember, finding the primitive function, if dy dx equals x to the n, then our technique for finding the primitive is to add 1 to the power, then divide by the power, plus the constant of integration. And we don't need the constant of integration when we're working with a definite integral. So if we have a look at how this works, then to find the value of the integral from 2 to 5 of 8x dx, then we first of all find the primitive. So we know that that's 8x squared on 2, so 4x squared. And we are going to evaluate that primitive with the values 5 and the values 2. So it's the primitive with x equals 5, so that's 4 times 25, or 100, minus 4 times 2 squared, so 4 times 4, which is 16. So the value of that is 84. Now that 84 also happens to be the area between the curve and the x-axis. And we're going to come back to that in more detail. But we're just adding to our toolkit at the moment. So our next one, the definite integral of 10x to the 4th. So we integrate that. That will become 10x to the 5th on 5, or 2x to the 5. We're going from 2 to 1. So when we put 2 in place of x, that will be 2 times 2 to the 5th, so 2 times 32, which is 64, minus 2 times 1 to the 5th, which is 2. So we get 62 square units. For our next one, the integral from minus 5 to 2 of dx, well, there's really a 1 in here. So that 1 integrates, or the primitive of 1 is x. So we're going for x from 2 to minus 5. So we put in x equals 2, minus, putting in minus 5, and we will get 7 square units. So if we drew up these curves, what we're doing is finding the area. So just very briefly, for that one that we've just done, if the function is y equals 1, then we know that that's the horizontal line passing through 1, and we're looking at it from minus 5 up to 2, and clearly that's a distance of 7 times 1. So this area is what the definite integral represents, and we know geometrically that's 7 square units, as we've found before. So we then have something like this next one. I'll just rub this out to give us a bit of space. So for our next definite integral, we can see that we've got a product, but there is no product rule for integration. The little asterisk means that actually there is a sort of a product rule, but it's in extension 2 maths. We don't have to worry about it. So what do we do if there's no product rule? Well, we actually change it from being a product to start with. So we rewrite our expression here by making it, instead of a product of 2 terms, the sum of 2 terms. So if we multiply the x squared into the bracket, which is sort of goes against the grain, so it's 5x to the 4th, why it shoots that bit up there, plus x squared dx. And we just integrate each term then. So we're going to go, so this will become 5x to the 5th on 5, or just x to the 5th, plus x cubed on 3, from 1 to minus 1. We'll put our values into that, and we get 1 plus 1 on 3, minus, and we put minus 1 in, to the minus 1 to the 5th will be minus 1, plus minus 1 on 3. Go ahead and do our addition then, and we get 2 2/3 square units as our answer. Now for our next problem here, we've got a quotient, but there is no quotient rule either. So if we have a quotient, there must be some way of us simplifying it algebraically. And in this case here, we could say either that we can take out an x as a common term from up the top, or we possibly don't even need to go that far. We could just say that we could take each term on the top and divide it by the bottom. So x cubed on x becomes x squared on x becomes x, and x on x becomes 1. And that's what we're going to integrate. So don't forget we haven't yet integrated it, we've just rearranged it. Now we do the integration, so that's x cubed on 3 minus x squared on 2 plus x. It's definite, so we've got our limits of integration. We plug our numbers in, so when we put 3 in, we've got 27 on 3, which is 9, minus 9 on 2, plus 3, minus what we get when we put the 1 in, which will be 1/3, minus 1/2, plus 1. Then we go to the calculator if need be, and we get 20 on 3, or 6 2/3. So, have a go at these out of 11b now.